What is the total number of oxygen atoms in 0.2 moles of glucose, C6H12O6? This is a common sense question. I'll show you how I calculate it. So the first thing I'm going to do is count how many oxygens there are in glucose. So we can see there is 6, so there's 6 times oxygens. So there are 6 oxygens in glucose. The second thing I'll do is, it says to 0.200 moles. So we know already if it was to 1 mole, in 1 mole of glucose, there are 6 oxygens. But because that's like something we just have to know, that in 1 mole, that's how much. The formula usually shows how much there is in 1 mole. To find how many oxygens are there in 0.2 moles, I just times it by 0.2 by 6 and I get 1.2. A key thing you're going to have to remember is Avogadro's constant, 6.022 times 10 to the power of 23. I don't think the data booklet gives it to you in the exam, but it's worth memorizing anyway, saves your time looking through the pages. It will come up in a lot of stoichiometry and quantitative chemistry questions. For maths, I rounded it down to 0 decimal places, so 6 times 10 to the power of 23 times the 1.2 oxygens that we've calculated, and we get 7.2 times 10 to the power of 23 oxygen atoms in 0.200 moles of glucose. And that means the answer is D. On the side, I'm just showing you how I got 7.2 in case your mental maths is difficult for you. So that's just a step-by-step breakdown of what we're doing. And the answer is D. What are the coefficients of H2SO4 and H3PO4 when the following equation is balanced using the smallest possible whole numbers? This is simply a balancing equations question, and the only way you're going to be able to improve on this skill is by practicing and practicing and practicing. If you Google online balancing equation questions, loads will come up. I like to split the left from the right, and then count how many of things there are on the left and how many things there are on the right. We can see that there are 3 calciums, there are 2 phosphorus, there is 12 oxygens, there are 2 hydrogens, and there is 1 sulfur. And on the right there is 1 Ca, there is 1 P, there is 8 O, there are 3 hydrogens, and there is 1 S. And I just want to see what I need to times by on either side to make them even. So calcium is 1 on the right and 3 on the left. Let's put a 3 in front of CaSO4. That means calcium becomes 3. Sulfur becomes 3 because we're timesing everything by 3. And oxygen becomes 16 on the right hand side. Remember to count everything on the right hand side, because I know sometimes you might miss a second little solution or something. We can see that on the left, S is 1, and on the right it's 3. So let's put a 3 in front of H2SO4. That means S becomes 3, H becomes 6, and O becomes 20. I think 20. Yes. And on the right, H is 3 and H is 6 on the left. So let's put a 3 in front of a 2. Oh my gosh. Let's put a 2 in front of H3PO4 to make 2 times 3, 6 H's. That means that P becomes 2 and O now becomes 20. And if you check, you've balanced both sides of the equation. And the question's asking you for the coefficient of H2SO4 and the coefficient of H3PO4. If we look at the equation, then we can see that there are 3. The coefficient is 3 for H2SO4 and the coefficient is 2 for H3PO4. Process of eliminations, good to double check your answers with. If we can see that D has 2 ticks, so the answer must be D. 7.102 of Na2SO4, molecular formula being 142.04, is dissolved in water to prepare 0.5 dm cube of a solution. What is the concentration of Na2SO4 in mole dm cubed? So the first thing I'm going to do here, like in every calculation question, I'm going to write down what the question gives me. And I'm going to highlight that as well to make it extremely clear that we are given this information. MR is 142.04 and the mass is 7.102. We aren't given the amount of moles, however. And if we know our formula, we know that moles is concentration times volume. Let's rearrange that to find concentration. It's moles divided by volume. We aren't given the moles of Na2SO4 in the question, so we need to calculate that. We are, however, given the volume. So moles with regarding M and MR is mass over MR. And so that's 7 over 140. I took away the decimal places to make it easier for the maths, which is 1 over 20 simplified. And if we know 1 over 2 is 0.5, then 1 over 20 must be 0.05 because we have to divide by 10. The second thing we're doing is writing our equation because we know we need to calculate this. So I'm just writing again, rearranging it again, and plug in the values. 0.05, which we've calculated for the moles, divided by 0.5 dm cubed, because that's given in the question, is not 70.5. Because we can, and an easier way to calculate it is take times the numerator by 10, divide that by the denominator. We can see that 0.5 divided by 0.5 is 1, and all we've got to do now is divide the answer by 10, so 0.1, and in standard form, 0.1 is 1.0 times 10 to the power of minus 1. And we can see in our answer it's B. How many atoms are present in 0.10 moles of PtCl2 NH3 This is similar to the glucose question that we went through earlier. It's actually the exact same count, but now they're asking for like the entire formula. They're not just asking for an oxygen, they're asking for what's like how many atoms are present in 0.10 moles of everything. So the first thing we've got to do is add up everything that's in PtCl2 NH3 1 plus 2 plus 1 plus 3, but then NH3 is times 2, so do another 1 plus 3. And ease that, just simplify that to make your maths clearer. 3 plus 2 plus 6, and there's 11 things in this, like PtCl2, NH3 And it says how many atoms are present in 0.10 moles. So all we've got to do again is 0.1 times 11, which is 1.1. And to find out how many atoms are present, you times that by Avogadro's constant. So 6.022 times 10 to the power of 23 times 1.1. I made it easier by taking away the decimal places because we're not allowed a calculator for the maths in the exam. So 6 times 10 to the power of 23 times by 1.1. And we can see that 6 times 1.1 is 6.6. And then simply plug on the decimal place. So it's 6.6 times 10 to the power of 23. And the answer is C. What mass of carbon dioxide is produced when 5 grams of calcium carbonate reacts completely with hydrochloric acid? So they give you an equation as well, which is extremely helpful. I'm highlighting everything that we need in the question again to make it extremely clear, as we said before, in the exam. Because these are only 1 markers, you only get 1 shot really at your question. It's like a mark a minute. And so you have to make sure you get it right on the first try. Don't make any silly mistakes. The question, and this is a higher level question, but standard level can revise from this too. When it says reacts completely, the IB like to do that. They won't give you the the answer bluntly. They won't straight away tell you it's an excess or it's a limiting reagent, because they want you to think outside of the box. So if it says reacts completely, it just means that CaCO3 is the limiting reagent. It's used up completely. So CaCO3, I'm plugging in the values that were given, and in your data booklet, you can calculate the MR of it. I calculated it to 100 zero decimal places for the maths to be easier. We know the mass is 5 grams, and so moles is mass over MR, molecular mass. So 5 over 100, 1 over 20, as we did before in a previous question, and we know that 0.05. The ratio of CaCO3 to CO2 is 1:1. And we want to find out what the mass of carbon dioxide is. So we know the moles has to be 0.052 if the ratio is the same as for CaCO3. CO2, so we can calculate the MR from the data booklet again. So I'm doing that. 14 plus 16 plus 16 is 46. The moles we've calculated to be 0.05, and we don't know the mass. So the mass is the number of moles times the molecular mass. 0.5 times 46 is the exact same as doing 46 divided by 2, and we'll get 23. 23 divided by 10. Oh, of course, because I did 0.5 times, I times it by 10 to make the maths easier. The maths, I mean, easier. So I just have to divide it by 10 again to make it 0.05 times by 46. And so it's 2.3, and it's the closest answer to 2.2, so the answer must be B. The volume occupied by 1 mole of an ideal gas at 273 Kelvin at 1.01 times 10 to the power of 5 Pa, which is pressure, is 22.4 dm cubed mole minus 1. What is the volume of hydrogen in dm cubed produced when excess magnesium ribbon reacts with 100 centimeters cubed of 0.200 mole dm cubed of hydrochloric acid? That is an extremely long question to read. So they give you a formula. I'm going to highlight everything that were given in the question again. The first thing I spotted, though, was when it said ideal gas, I looked at the equation. The only gas there is H2. So they ask, like, we know we need to calculate the ideal gas, like the volume of hydrogen, because that is the gas in the equation. So when it says is produced when excess magnesium reacts, excess means it cannot be the limiting reagent. Magnesium cannot be the limiting reagent. So 2HCl is actually the limiting reagent because it is limited. It's going to be used up completely. So I'm plugging in the values. The volume is in centimeters cubed again in the question. Remember to just convert to dm cubed. So the volume is 0.1 dm cubed. Concentration is 2.0. Moles is concentration times volume, and we aren't given the moles in this question. So 0.1 times 2 is 0.2 moles of HCl. 2HCl to 2H2, the ratio is 2:1. So divide that 0.2 by 2 to make the... Well, because the ratio is 2:1. Yeah, that's all you got to do. And you get 0.1 moles of H2. There are more 2HCl than H2 produced. Again, highlighting how hydrogen is the gas, therefore you must use the information about the ideal gas for it. It is the ideal gas in this way. Well, no, it's not. It's more like it's closest to what you need, like what is given in the question. So what I'm doing here is volume we know of an ideal gas is 22.4. And if we know the amount of moles of hydrogen is 0.1, I'm just timesing 22.4 by 0.1, which means you divide it by 10 and you get 2.24, and the answer is B. What is the whole number ratio of the coefficients of ammonia to oxygen when the following equation is balanced correctly? I'm highlighting that's the equation that we need to actually balance. Very similar to the coefficients question we did earlier. Just balance it. It's pretty much just that. So on the left, we can see that there is one N. There are 3 H's. there is 2O, there is one on the right, one N, two H's, and there are two O's on the right as well. The thing that isn't in balance is the hydrogen. So on the right, we see it's 2, on the left it's 3. 2 times 3 is 6, and it's a nice number because you can multiply the left 2. So let's put a 3 in front of H2O, and that becomes, the hydrogen becomes 6, and the oxygens become 4, the amounts there are. On the right, just type, like 3 times 2 is 6, so put a 2 in front of NH3, the hydrogens become a 6, and the nitrogen becomes 2. But on the right, nitrogen is still 1. So we put a 2 in front of NO, and so nitrogen becomes 2, and oxygen now becomes 5. Now this is one of those tricky questions. You are allowed to use decimal places when balancing equations. However, your end answer should not include any decimal places. Try and make it whole numbers when you finish your answer. But over here, it's going to be difficult because I tried earlier balancing the oxygens without using decimals. It was very difficult to do. So if we can see on the left, O2, there's only 2 oxygens, and on the right, there are 5 oxygens. 2 times what is 5? So if we know that 2 times 2.5 is 5, let's put a 2.5 there and see if it balances the entire equation. And oxygen does become 5 on the left. So the equation is balanced. However, you cannot, and I don't encourage it, leave your answer in with decimals. So as I'm writing over here. Try and keep whole numbers. Cannot stress that enough for an exam answer, because I don't think they would award you full marks. So to make 2.5 a whole number, simply times it by 2. And so that means you got to times all of the coefficients by 2. And so you get on the left 4, 5, and on the right 4, 3. So you want to know the ratio of coefficients of ammonia to oxygen. So just actually look at the left only, and we can see the ratio is 4 to 5 because the coefficients are 4 to 5, and so the answer is C.